Let us discuss behavior near the asymptotes. Question here is, discuss behavior of the function near the asymptotes for f of x equals to 6x plus 1 divided by 9 minus 3x. So this rational function will have both horizontal and vertical asymptotes. Let's first discuss vertical asymptote, right? So let's write vertical asymptote. And then figure out how does the function behave when it is approaching vertical asymptote. So vertical asymptote for the function is when denominator is equal to 0, right? That is to say when 9 minus 3x is equals to 0. So 9 minus 3x equals to 0 will give us a value of 3x equals to 9 or x is equals to 3. So at x equals to 3, we do have a vertical asymptote, right? Let me just sketch this out for you. So I'll sketch it here and then we'll discuss. So what we see here is that at x equals to 3, we have a vertical asymptote. So let me draw a vertical line here representing a vertical asymptote for x equals to 3. So this is x equals to 3, right? So this point is 3 for us, that is x-axis. This is y-axis, and that's the origin. Now when we say behavior near the asymptote, it really means that if we substitute a value which is very close to x but from left or right side of 3 for which we have a vertical asymptote, then how does the function behave? As you know, at x equals to 3, the function kind of is infinity, or x equals to 3 is not in the domain of the function, right? So x equals to 3, we have a vertical asymptote. That means we have a restriction here, and so the function cannot be equals to 3. So that is a restriction on the given function. But we can always approach this function, and we can approach it from either side. That means we can approach the function from the left side as well as from the right side. Now to find the behavior, what we can do is substitute a value which is close to 3 on either side. So we can say what is the limit of the function, that is, what is the limit of the function when x approaches 3 from negative side. Negative side means where our test point is less than 3. Let us say our test point is 2.9. So if I plug in 2.9 in this equation, then what happens? Do I get positive infinity or negative infinity? This is the question which is being asked, or it is to be answered, right? Now if I write 3 here, then 3 times 3 is 9, and 9 minus 9 will be 0. But if I write a number less than 3 here, let's say 2.9, then 3 times 2.9 is going to be less than 9, right? So our function f of x at this instance will approach infinity but positive infinity, right? So that is how you can test it out. Just plug it in a small value, just a shy smaller than 3, right? Let's say 2.9. We call this as a test point. So when you substitute x with 2.9, right, numerator will be positive, but denominator will be also positive. 3 minus something which is less than 9, right? So I'm not really calculating this, but I'm just telling you it could be 8.7 in this particular case. Anyway, it could be any value, right? It could be 2.99, giving you a positive value. So we are actually interested in this sign. So what we notice is that when we are approaching from the left side or 3 minus, then we are approaching positive infinity. That is what it is, right? Now let us consider the same function or the limit of the function when we approach 3 from the positive side. What happens to the value of function? This is what we need to answer. So for this, what we can do is we can put a test point as 3.1, right? So if 3.1 is placed here, 3 times 3.1 is going to be more than 9. In fact, it is 9.3, right? So denominator will be negative. Since that is negative, numerator is positive, then we get a negative answer, right? So the function approaches negative infinity. Is it okay? That means when you are approaching from the right side of 3, then the function approaches negative infinity, and that is what we call behavior of the function near the asymptote. I hope you get the point, right? Now let's consider horizontal asymptote. Now what is the horizontal asymptote for this function? Well, the horizontal asymptote is the ratio of their leading coefficients, since the degree of numerator and denominator is same. So you could write straight away the answer. That's one way of doing it. Second way is to find the limit of the function as x approaches plus or minus infinity, right? So let's do that part, and then let's check, do we get the same answer? So we are expecting 6 over minus 3 and minus 2 as our horizontal asymptote, right? So let me write down the answer first, and then we'll check it out. So we are saying horizontal asymptote should be y equals to 6 divided by minus 3, which is minus 2. So that is the horizontal asymptote for us. Is it really the horizontal asymptote or not is something which we are going to show with the help of limits. So you find limit of this function at x approaches plus infinity for time being. So it's a limit of the function as x approaches, let us say, plus infinity. And I'll take or factor x out from the numerator. So I'll factor out x. Then I'm left with 6 here plus 1 over x, correct? And in the denominator also, I'll factor out x. Rather, let me take minus x outside. It's good to have this positive. So I'll have minus x factored out. So I get here 3 minus 9 over x, correct? That's what you get. Now we can cancel out x and x. And what do we get? We get limit x approaches infinity. And as you can see, if x is a very large number, 1 over x will be 0. Same is the case with 9 over x. So we are left with 6 over minus 3, right? Minus 3. So that is the horizontal asymptote for us. So we got the same horizontal asymptote which we expected. As x approaches plus infinity, the function approaches 6 over minus 3. Now, even if you do with minus infinity, for example, if next time you do with negative infinity, even then this is just a constant. So the function approaches minus 2. Do you see that? So our answer is minus 2. So for this case, for any rational function in that matter, if numerator and denominator degrees are same, then equation of horizontal asymptote is ratio of their leading coefficients. So we have horizontal asymptote at minus 2. So let me draw this horizontal asymptote here. Let us say this is minus 2 for us, and we'll draw this as our horizontal asymptote. Now equation of this horizontal asymptote, as you have seen here, is y equals to minus 2. So we have y equals to minus 2 as our horizontal asymptote. Now let's see the behavior of the function as x approaches plus infinity and minus infinity. Now what we are trying to figure out in this case is, do we approach minus 2 from above or below? This is what we're trying to figure out, right? So let's rewrite this function here and then see, are we approaching it from the positive side or from the negative side, right? So if x is a very large number, then we know 1 over x will be 0 and minus 9 over x will also be 0, right? So what we will do here is, we will plug in a large number. So you can use calculator also. So you can plug in a large number here and see whether your answer is minus 2 point something or it is minus 1 point something. Do you understand? If it is minus 1 point something, you are approaching from the top. If it is minus 2 point something, then you are approaching from the bottom of this. This is what we are trying to figure out, okay? So that is what we will try to figure out. We are approaching from positive or negative, right? So the best way is just plug it in and calculate, right? So let's write down, let's use the calculator, and then we'll do 6 times, let's use the number 1000 for example, plus 1000. So we have 6 times 1000 is 6000 plus 1. So we got 6000 plus 1. and we'll divide it by, within brackets, 9 minus 3000. Bracket close, equals to, we get minus 2.9. So we get a number which is negative and which is more than So when we plug in positive 1000, what we get is minus 2 point something. That means more negative. So that means we are approaching, when we are approaching from positive infinity, we are approaching from the lower side. Do you understand? So that is what we get. Let us say we substitute a value plus 1000 for x. So x equals to plus 1000. What do we get? We get the function is approaching minus 2 from the plus side. That means below it, right? So more negative, I mean, under it. So we should write actually negative because more negative, right? More negative. Now if I substitute x equals to minus 1000, what happens to f of x? So in that case, in this case it is 2 point something, minus 2 point something. So we are approaching from the downside. Now when we substitute x equals to minus 1000, what do we get? So we get in the numerator minus 6000 plus 1. So I can write this as 1 minus 6000 equals to, divided by, within brackets, 9 plus 3000, right? That's a positive quantity, which gives me a negative less than 2. Do you see? Less than 2. So in this case, we are approaching from top. Do you see that? So that is what happens. We get something like minus 1.999 something. So that is what I'm trying to say. So behavior near the asymptote is what happens when we are approaching x. We know we are approaching the horizontal asymptote. Are we approaching it from above or from below? That is what the question is. So in this case, we are approaching from below, and when we are approaching positive infinity, as you can see here, and here we are approaching from above. So that is what is the behavior near the asymptote, and that makes sense, right? Now if you need to sketch this function, you know your graph is something like this, correct? That is your graph going to look like. And of course, if you find x and y intercept, you can actually sketch a very accurate graph for the given function. We'll see sketching graphs later, but first let's understand very clearly how to find asymptotes and the behavior of the function near the asymptotes. I hope with this knowledge you are able to appreciate curve sketching and sketch much better curves. Thank you and all the best.